All right, what I'd like you to do to start the notes today is, in your own words, write what you believe similar polygons are, or if you feel more comfortable, you can just write what you believe two things or what would make two things similar. But let's put it in your own words, and then I will unveil the book's words and see how close you are to that. So take a few seconds to do that. All right. In the past, I will say people have done an excellent job of putting things in their own words for this one. And actually, let's face it, some people have done it in a very simple fashion, and it doesn't have to be an elaborate, three-paragraph definition about a similar polygon here. Would anybody like to share what they came up with, Steve? Okay, so multiple polygons that have congruent angles but not sides, very good start. The angles being congruent, very important. And multiple meaning more than one polygon, very good. Chris? Okay, very good. Polygons that are alike in proportion. I think if we put Chris and Steve's definitions together, it's absolutely perfect. Because the angles have to be congruent and the sides have to be, a word from yesterday, proportional. Those are the key words right there. Uh, Polygons with corresponding angles congruent, and the measures of the corresponding sides proportional. So probably the keys there, again, hit on by the two gentlemen there, that the corresponding angles are going to be congruent and the corresponding sides proportional. Remember, proportional means that they'll have equal ratios. Okay. Yeah, that's a really bad color. I should probably get that on there. There you go. Well, it did highlight it just very poorly. So I think we'll just leave it up there like that now, so I don't mess it up again. So really, yeah, in the end, I think putting our definitions together, we did a pretty good job. And some stuff people have said in the past is polygons that are the same shape but different sizes. I'm like, well, that pretty much covers it too. Very simple, and it doesn't necessarily have to be the book's words. So what I suggest you do here is go by the one that makes most sense to you, whether it's the ones you wrote down or what the book has. So let's take a look. It says determine if they are similar. And so what we have to do first is let's check, are those angles congruent? A lot of people skip over that step, and then they get a ton wrong. If the angles aren't congruent, they have no shot. Okay, so is this, first off, are these two polygons? Yeah, triangles, that's a type of polygon. And so right here, we've got 14 degrees matching 14 degrees, so we're off to a good start. Over here, we have 28 degrees, or 26, sorry. Would this also be 26 over here where I just put the red dot? How do you know? Just because it's the problem I made? Or did you actually do the math? Yeah, we got 140, we got 14. How much is left over from the 180? 26. So are we off to a pretty good start? Yeah, I think we are. Because then this angle up over here, it has no choice but to be 140. So are the angles congruent, which was part of the similar definition? Yes, we're off really good start. Now what we have to do, though, which can get a little bit more complicated, is we have to check and make sure the sides are proportional, meaning do they have the same ratio? And so what I would do is say, well, let's just start here with 4.5, put it over. Well, which side does it match up with? Which is the corresponding is 2? Very good. Those are the ones that are corresponding, because in triangles it's across from 14 and across from 14. Let's face it, could they have turned this triangle over here or reflected it or done various things? Exactly. Just watch the angles and go from there. And so that better equal, well, here's 7.65. Notice how I went back to the one I started with. All right, I'm following the same pattern every time. You can't just jump around when you do this. I went from here, 4.5 to 2. Now I'm going to go 7.65 to 3.4. Very good. That would be the corresponding right there. And then what we would have to do is make sure that 11.7 to 5.2 is the exact same thing. Now I chose a relatively difficult one to see to start off with, because what you could do if you wanted to is you could say, does that times that equal that times that? That would be fine to check that. And if that works, then say, does that times that equal that times that? And then that would show that it works off. But I think the easier way when being asked about similar is, why don't we just find out what those decimals are on each one and find out if they're the same? So somebody do 4.5 divided by 2. Maybe this side of the room do that one. 7.65 over 3.4. Let's have the middle of the room do that one. And then 11.7 over 5.2. Have the left side of the room do that one. And let's see if we come out with that same decimal. All right, first group, what do we get? 4.5 over 2. Haley. 2.25 is that one. All right, middle group, what'd you get for 7.65 divided by 3.4? So are we doing good so far? Now, do I just check those two and we're good? We don't have to worry about the third one? No, you've got to check. You've got to make sure that it works. What do we got over there on the left side? 2.25. So do they have the same ratio? So are they proportional? Yes, they are. So are they similar? Yes. Okay. Now, the symbol for similar is just one squiggle, just like that. So these two are similar. Steve. Okay, the question was, do all of them have to basically have the same ratio? To be similar, yes, they do. Have to all have the same ratio. It is very possible that we could go 2.25, 2.25, and then 3, but then we would say no for similar. That those objects could be out there, but then would not be similar. So any questions? Okay, so determine whether each pair of figures is similar. Justify your answer. Well, let's take a look at this one. What's the first thing you should look for? Angles congruent, exactly. Some people skip over that step, like I say, get a lot wrong. So on this bottom left here, we have 3 markings in that angle. Do we have 3 markings in an angle over there to say they're congruent? Yes, we do. Then we got 2 and 2, 1 and 1, and 50 and 50. And for those that are listening to this recording, that uncomfortable silence was because I was staring at a student that has not shut up since he's entered the room. So now the angles are congruent. These are quadrilaterals. And so now we got to check the ratios, but you notice I have reflected this time. So you have to be careful. So on this one, does it matter which object you start with? Do you always have to start with the bigger one? No, you can start with the smaller one. Doesn't matter. Just make sure you match it up. So let's say we wanted to start with the 10. All right, so we'd say it's 10 over, but you got to make sure you match it up. A lot of people are going to want to say over 6. Realize we're going from the 50-degree angle to the one with 3 markings, so you got to do the same thing there, and so it is 15. And our question is it going to equal all the rest of them? Okay, so 10 and 15, those definitely match up. And does it matter which one I go to next on the left one? No, let's say we wanted to go to 7. So it'd be 7 over, but now it does matter where you go on the next one. You better make sure you go to 10.5. So can I go to 8 next? Is that acceptable? Yeah, so let's say you wanted to do that. So 8 2, 12. Is it okay on the last one then to go to 6 to 4? 6 over 4 on the last one? No, because you went from the right to left. And you got to just keep your pattern. Okay, so we'll go 4, 2, 6. So we know the angles are congruent, so we're good so far. So now we've got to check these ratios and make sure they work out. All right, well, so you do 10 divided by 15. And when we do 10 divided by 15, what do we find out? What is it? Is it 0.6 repeating? So in other words, 2/3, or if you want to write 0.6 repeating, that's fine. Is 7 over 10.5 also 0.6 repeating? It is? Okay, so far, we're doing very good. How about 8 over 12? It is 0.6 repeating. Okay. Is 3 out of the 4 good enough? Well, we got to make sure all of them have that same ratio. How about 4 over 6? That's probably the easiest one to see that that's 2/3. So all 4 are proportional. The angles are congruent. We're good. They are similar. And what's that symbol again? Just one squiggle. Yes, Steve. Okay, great question. I was hoping somebody would ask that on the first one. What if you do go the other way? Is it okay to go 15 over 10 and then 10.5 over 7, 12 over 8, and 6 over 4? As long as they all still come to the same ratio, it's fine. Will it be 0.6 if you do it that way? No, it's going to be 1.5 if you do it that way because it'll be 3 over 2. But they will all say 1.5 if you do it the other way. So it's okay as long as you follow the pattern. What you can't do is what I asked you at that last one. Can I just flip the order in which I wanted to do it and take, say, 6 over 4? Well, that you can't do because then it's obviously not going to work out because you didn't keep your pattern. Okay? So very good question. So now it says determine the value of x and y for each of the following. I'm basically telling you that A, B, C, D, and E, F, G, H are, wait a minute, there's that little symbol. What's that again? So I'm telling you they're similar. I'm not asking. I'm saying they are. So now you got to make sure the angles are congruent. The sides are proportional. So we take a look. Okay, so let's at least find our variables. Well, x is at the bottom of this quadrilateral over here, and y is at the top of that one. Well, let's take a look. Do we even have to worry about angles on this problem? No. Could I give you questions that deal with the angles? Sure, I could. But this one right here, I did not do that. Well, let's take a look here. Well, x is sitting right down here. And which one does that correspond with? It kind of corresponds with 8 over here. So if you follow that pattern, we could very well go x over 8 if you wanted to. Is it okay to go 8 over x? Yeah, as long as the rest of the time you follow that. Well, then I need to know what the ratio is supposed to be for this problem. So you take a look at this problem. Do we have the ratio of the sides anywhere? Do we know the numbers anywhere that'll help us? Well, I'm looking right here, and I see a 2. And what does that correspond with in the other one? 4. Which one? The one on the right, yeah. In this case, it does not matter. The question was, does it matter? In this case, it doesn't because there's also a 2 here. But be careful, take your time, and make sure you match it up properly. So should I put 2 over 4 or 4 over 2 if I'm going to follow the pattern we started with? 2 over 4 if we're going to follow the pattern. Right? This, again, is one of the easier proportions that some of you probably already know the answer just by looking at it. Right? But if you were going to do it kind of a little bit slower method for these, it would be 16 equals 4x, divide by 4, and x better be 4. And you can write it down there if you want. X has to be 4. And if we're going to set up y, I'd say why don't we just stick with the 2 over 4 again. Now if I set 2 over 4, what should be the other ratio to help me figure out y? Are you sure it's 5 over y, or is it y over 5? 5 over y is correct. Because you got to follow whatever pattern you started. And once again, pretty straightforward on the math here. You take that is 20 equals the other diagonal of 2y. Divide by 2. Y is 10. Yeah, basically, a lot of you probably looked at this one and noticed the one on the right is 2 times the one on the left, and so that pattern does have to follow, or the one on the left is half the one on the right. Either way, that does have to follow if they are similar, which we were told in the beginning that they were similar. Okay? So why don't you go ahead and try letter B? If you have not done so already. All right, let's see how you did. I chose this one obviously on purpose to see. There's a few mistakes that some people will make on problems like this. So these two pentagons that we have here are definitely polygons. We were told they are similar. What a lot of people mess up on, though, and I did put the markings right, they look here and think that this side and that side have to be exactly the same. That's if they're congruent. We're just saying they're similar. Big difference. So we're saying that those two sides have to be proportional, not necessarily congruent. Okay? So you got to watch out for that. Yeah, let's pray that. So does it matter which variable you solve for first in this here? Not really. Is there one that's maybe a little bit easier than the others? Yeah, maybe. Depends. Let's go for z first. Z plus 5, or plus 45, excuse me, has to equal what in this problem? So the angles aren't proportional? No, the angles have to be congruent. So z better make that angle, say, 100, right? And so we would subtract 45, and z better be 55, right? So that's going to make that part work out. Well, now here's what might have got some of you. Well, yeah, I got a 5 right here for AB, so then there's also a 5 down there for ED. How do you know that? Because of the congruent marks, right? So over here I have an X word right there. So, well, we know we could go something like this. We could go 5 over X. And if I do that, well, where do we actually have numbers that we can use? Well, we've got 4 and 16. Now, if I'm going to set up that ratio, should the 4 be on top or the 16 be on top? Based on my pattern, yeah, 4 better be on top. So 4 over 16. Now that I have it down in the proportion, is it okay to simplify the 4 over 16 before I do the math? Yeah, now that it's down there, you can simplify it if you want. I don't know if any of you have been doing that. But to simplify this, it becomes 1/4. Does that make the math maybe a little bit easier? It's possible. You can do that. So x equals, well, that saved me a lot of time. It pretty much got me right to the answer. So that was definitely worth it in that case. And is that it then? So we also have a y in this particular problem. So once again, some people, as they're done, they think that y plus 2 has to equal the 5 over there. It'd be great if it was that easy, but that's not quite how that one works. But we do know that 5 and y plus 2 are corresponding, so they do have to follow that same ratio. Again, so you could go, if I'm going to go this way, would it be 4 over 16 or 16 over 4? 4 over 16 again. And let's face it, is it okay, once again, now that I have it set up, to just make 4 over 16 1 over 4? It's fine. And I would do that whenever possible. And so we got y plus 2 times 1. Well, that's y plus 2 equals 20. Subtract 2. Y is 18. So have we solved for all variables? Yep. And we have made sure that they would have to be similar. Heather. Very good. I was going to wait and see, and I did it in that particular order to see if anybody would notice this. In the end, didn't we know x down here was going to be 20? And wouldn't y plus 2 have to equal 20? It would. Very good. And I set up that proportion and kind of avoided that to see if anybody would point that out. That's excellent. And really, didn't we come to that same algebra right there? It still worked out the same way, but yeah, much quicker. As Heather said, it'd be way easier to do it that way. Steve? Probably not on that one, but I wanted us to solve for them all. Probably just a typo on the directions. Again, Steve was asking, did we really have to solve for z because it wasn't in the directions? But yeah, we'll say we had to solve for all of them. Any other questions? All very good ones today.